Okay, so the work that I'll be presenting today is an extending some of the work that I talked about last year. We are a research group based out of both the University of North Texas and then colleagues at the University of Illinois at Chicago. We have my co-principal investigator, Cornelia Caragea, is in the computer science department up at UIC. And then we have a team of 3 graduate students, 1 at UNT and then 2 at UIC that have been doing a lot of this work with us. So I'm going to give a little bit of background just to stage, to frame where we're actually coming from with this work and the series of work, why we're doing what we're doing, and then hopefully trying to make it clear where we're going in the future with it. A lot of this project that we're currently working on started in 2017 with a grant project we received from the Institute of Museum and Library Services, which is a federal funding agency in the United States. And we were interested in exploring how we can use machine models to help us identify high-value documents in our web archives. And we had 3 use cases we were looking at in the United States: the state-level publications for all 50 states. We were interested in federal technical reports housed in the .gov domains. And then we are also looking at a use case of identifying faculty publications from domain crawls of university domains. It was a fun project. We did some research, wrote some papers, and one of the components that we had out of that project, one of the deliverables, was a white paper where we were doing qualitative research with government information professionals and really collections professionals in general, trying to understand how they make decisions. And when we started to talk about how they frame what they collect and what they have collected, they all answered, well, we look at our library catalogs because that's where we've stored information for decades and about the collections we hold. That is our knowledge base. And so that led us to propose a new grant where we were interested in trying to leverage that bibliographic metadata as part of the training of models so we could try to improve these models. So we weren't just taking the content as itself, but also trying to take some of that legacy information and incorporate that into the model building. And so we were awarded an IMLS grant in 2022 to start this. With 3 main research questions. How can we use this to improve the process? How can we reduce the human effort? How can we also improve, make this useful and include unlabeled data in our data sets? And how well does this transfer from one domain to another? And in this context, when we're looking at state information, state publications, how well does this transfer? So from Texas to Michigan to other states. We did research on why this was an interesting thing. So we were specifically focusing down on the Texas or state information. We were focusing on texas.gov. We saw that as a generalizable problem. All 50 states are interested in collecting their state output as part of their government documents programs. 48 of the 50 have recognizable digital publications, data sets or databases and collections that they're building. 34 of those 50 have some sort of web archiving program. So for us, it said there's at least 34 that are collecting using web archiving. It would be great to be able to extract those publications and put them into their digital publications collections. And so how can we assist with that process? So the overview of the project, it's, as I said, a collaboration between UNT and University of Illinois Chicago. And we also have partners with Archivit and the Library of Michigan to be able to use some of their data sets so that we can have more than just the Texas data sets that we're working with. And as I mentioned, there's 2 primary investigators and 3 graduate students who have been really great on the project. The data scope that we're looking at is For the Texas State publications, we're looking at Dublin Core-based metadata records from the UNT digital libraries. One of our collections, our Texas State Publications collection. We're also looking at MARC record data from the University of North Texas catalog related to the Texas government documents collections. And then a web crawl from texas.gov, primarily from 2012, and then also including some data from 2023. From the Michigan side, we're looking at Dublin Core records from their publications collection, MARC records from their library system, which covers the collecting of the State Library of Michigan, and then Michigan.gov collection that they used Archivit as a tool to collect. There are 4 different approaches data-wise that we're looking at in the project. And starting at the top, so in the 2017 grant, one of the outputs we had were 3 data sets that we created, which were fully labeled data sets. They were very small in the grand scheme of a lot of machine learning projects. But it was actually a very time-intensive process to go through, identify a random set of PDF documents, and then work with subject matter experts to go through and say, would you collect this? Would you not collect this? Would you collect this, based on their collection development policies and their expertise with their collections? So we have labeled data sets. We have positive-only data. We have labeled data, unlabeled data, and then bibliographic metadata that we're working with. Starting at the bottom, the metadata data sets were from the 2 sources, and you can see the number of records. The distribution on all of these is all over the place as far as what we have, but we have a reasonable amount of bibliographic metadata that we're working with. The data sets were harvested or created in 2 ways. We either harvested the Dublin Core metadata using OAI-PMH from the digital repositories. We downloaded the MARC records from the various ILSs, so the different catalogs. We converted everything to a standardized Dublin Core metadata set, just so we lost some of the nuance in the MARC records, but generalized it for people that don't really need to deal with the MARC records. We converted that all of the XML into just standard, or just to simple line-oriented JSON files. One of the challenges that we kept running into is, as we would bring on graduate students, they just kept looking at this data like, what are you guys doing? And so it was just, how can we simplify and still retain the kind of the important components, but made it easier for them to work with in the models and the paradigms that they're dealing with, which is, 1, not XML. It's all JSON, and then going from there. And then we developed some scripts to go through and do some analysis so that we could actually quickly understand the data sets that we were working with, and just some examples of the output of those, and then the tools that we've developed for those, just simple scripts for processing and displaying that information. So building the labeled data sets, as I mentioned, was very time consuming. It involved identifying a collection, extracting all the PDFs, verifying that all the PDFs would be good candidates for this kind of work, which means that they needed to be actually full text PDFs. They couldn't be restricted in any way. We needed to be able to get at the text. They couldn't just be scans without OCR backing. We then we deduplicated everything based on hash. We created random samples of 2,000 PDFs per data set. We then sent those off to our subject matter experts with instructions on high level how to label, and then we pestered them for weeks and weeks and weeks. Did you do this? Did you do this? Did you do this? Because it's not a fun task, and we're getting highly skilled professionals to do this work. And so really they were deciding whether or not they would collect this based on their collection development policies, or if they would pass on that and not collect it. And this is just an example. You end up with tons and tons of work for 3 columns of data. The PDF, the type it was, or if it was in scope of being collected or not. Labeled data sets, we've got 4, and then we're finalizing the Michigan data set, which is one that we added to this so that we could start to do some cross-domain research. So these are publicly available in the UNT Digital Library. Another set that we worked with is just for positive-only data sets. So one of the use cases that we had is it's actually pretty straightforward for us to give you examples of things we did collect as examples of things that we would collect. It doesn't always match one-to-one, but it's pretty close. And it allows us to help with situations where we have really highly unbalanced data sets. So for example, some of the labeled data sets, we would start with 2,000 PDFs and we'd end up only having 300 items we would want to collect, or maybe fewer. And so to be able to raise the parity in labeled or positive versus not, we have positive-only data sets that we made available for this kind of research. Then the other piece that is involved is just unlabeled data sets. So these are sets of PDF data from the same distributions of the original data sets that can then be used for additional types of machine learning models and to do different types of experiments. And so making all of these available to both our research team, but then longer term so that we can have kind of examples of the kinds of data sets that are useful from web archives for our research teams to work with. So these are all available for downloading and kind of give us an idea of what they are. And so the current grant activities, we're in our second year. Most likely it's going to be a third year on a 2-year grant. That's just how they go. UNT and UIC are working through various experiments, developing pipelines that we can share, getting graduate students to talk to each other between institutions and then share information and share code and not all decide they want to start from scratch every time is really challenging. So we've found that just early results on the incorporation of bibliographic metadata is actually really, really impressive on how well it improves some of our models for extracting. And in fact, there's some of our models, we're able to start with just bibliographic metadata and add very, very few 10, 20 examples of labeled data and actually perform better than we were with like much larger labeled data sets. So we're able to then go into a situation where we could work with a library, say you have a web archive, give us a collection of your metadata, we'll create a model, and then with a few labeled examples from their web archive collection, we would then be able to go through and at a pretty high confidence extract content that would meet that historic collection development policy. So that's all really exciting. And then currently we're building out experiments with the positive only and then the unlabeled data, which is its own track of process or of machine learning. One interesting thing that I find in working with the graduate students, there's a lot of discussion on the large language models, a lot of the very large compute that get involved in. A lot of these students are really interested in how we do this at a small level, how you can do this on small budgets because they don't have these grand budgets. So it's really exciting to see them, you see their eyes roll, like they roll their eyes when you start talking about the cost of these and they recognize, so it's really nice to see that in the graduate students. They understand that some of this work is just not sustainable for them as professionals and they're really in tune to that, which is really exciting to see. So how can we do this at small institution scale where we're not just relying on $100 million investments by corporate companies. So it's really great to see. And so more information from the website and then all of the code models and data are available, either available or becoming available on the GitHub page listed there. And thank you. You can contact me or any of the team. And then we've got a few minutes for questions.